Hello everyone, in today's tutorial we will learn the design and assembly of internal gear with sun and planetary gear in SOLIDWORKS, and we will cover the material selection for internal gear. Along with that, we will see how to make this motion study animation. So let's get started. When we open SOLIDWORKS, first select new, select assembly, click OK. This window will automatically pop up to select our old files to assemble. For now, we'll cancel it because when we select assembly, then we can make gears by using toolbox and assemble it directly. So first of all, we change this IPS to millimeter gram second. Now select this front plane, select sketch. Now we have to draw 4 circles. So short key to select circle is hold your right key of mouse and drag your mouse towards right. And now we'll draw 4 circles. This small circle is for planetary gear and this is also for planetary gear. Now we will give dimensions to it. So select smart dimension. Short key to select smart dimension is same as circle. Hold your right key and drag your mouse upward. Now select this circle and give dimension 220 mm. Select this circle, give diameter 90 mm. Select this one and give dimension 65. Now select this circle, hold the control key and select this circle and give relation equal. Now select this circle and this circle, give relation tangent. Again select this one and this circle, give relation tangent. Now select this center point, hold the control key, select origin, select this center point and give relation vertical. Now our sketch is fully defined, so exit the sketch. Now we will bring our internal and spur gear. For that, go to the SOLIDWORKS design library, select toolbox. If you don't have toolbox option here, select this small arrow besides of option, select add-ins. Here SOLIDWORKS toolbox library, select this toolbox and click OK. Now again go to design library, toolbox. Here we have so many options. If your values are in inches, then select ANSI inch. ANSI is American National Standard Institute, so you can select that. Our values are in millimeter, so we'll select ISO. Select power transmission, select gears, and here drag and drop this per gear. Remember one thing here, if you have selected assembly option, then only this menu of configure component will open directly. If you have selected part, then this menu will not open directly. Okay, for now we have to change these values for our sun gear. So we'll select module 6. Number of teeth, we'll select 15. Pressure angle, we keep it 20. Face width, we'll select 30. Hub style, we'll select type C hub. Type C means it provides hub at both sides. Hub diameter, we'll change it to 50. Overall length, we'll change it to 40. Nominal shaft diameter, this small hole is nominal shaft diameter, so we'll select 20. Keyway, Here we have two options, square 1 and square 2. We'll select square 1. It will provide one slot for key. Square 2 means it will provide two slots for key. So these are our values for sun gear. Click OK. Now system will automatically copy it. Click your left key of mouse to drop it. We need only one, so cancel it. Now this is our planetary gear and this centermost gear is our sun gear. So right click on planetary gear and select edit toolbox component. Now we have to change these values for our planetary gear. We'll change this module. We select 5.5. Module is basically pitch circle diameter divided by number of teeth. Number of teeth, we'll select 11. Pressure angle, we keep it 20. Face width, we'll keep 30. Hub style, we'll select type A hub. Nominal shaft diameter, we'll keep it 20. Keyway, we'll select none because we don't need keyway here. So this is our planetary gear. Click OK. We need two planetary gears. So we'll copy this gear. For copy, we have to hold the control key, select this gear and drag this towards left. Now this is our second planetary gear. Right click on the second planetary gear. Select edit toolbox component. We need to do some changes for second planetary gear. So we'll select module 6. And number of teeth we'll reduce. We'll select 10. And we'll keep these things as same as first planetary gear. So click on OK. Now we'll bring our ring gear or internal gear. So drag and drop the internal spur gear and leave here. Now we'll change these values for our internal gear. Module, we'll select module 5.5. Number of teeth, we'll select 40. Pressure angle, we'll keep it 20. Face width, we'll select 30. Outside diameter, we'll select 250. But remember one thing here, these all values for sun gear, planetary gear and ring gear are random values. You can select as per your calculations and requirement, then click OK. Now select on this main sun gear and select float. Now we'll rotate these all gears. Select move component, select rotate component. And try to rotate all gears. And click OK. Now we will bring all these gears in single plane. For that, select mate. Select front plane. Select this surface of internal gear and click OK. Do this for all gears. Select front plane. Select this face of sun gear. See relation coincident. Click OK. Again select front plane. Select first planetary gear. Select OK. Again select front plane. Select second planetary gear. Select OK. Now select this circle and outer diameter of ring gear. Select relation concentric. Click OK. Again select this circle and select this hole. Select relation concentric, click OK. We'll move this gear for simplicity. Now select this circle and select this hole. Again concentric relation, click OK. Select this small circle and this hole and click OK. Now click OK. Hide this sketch. Right click on the sketch and select hide. If you want to see your gears collide or not, select move component. First select standard drag and simply move it. And leave some clearance between teeth. Then select physical dynamics and try to rotate your component. If gears are not meshing properly, then system will detect collision. So these gears looks perfect. Click OK. Now look at the important aspect of material selection. These gears can be made of all sorts of material including brass, bronze, cast iron, ductile iron and plastics. We'll select steel because steel is the most common material overall and it offers higher resistance to wear and have high strength. It's not rule to always select steel because the material selection based on strength calculation, available space and cost of materials. So you can select material based on your calculations and requirement. For now, we'll select steel. Go to appearance, select appearance, select metals, select steel and drag and drop this polished steel and select body. Do this for all gears or else you can copy and paste the appearance. Right click on the ring gear, select copy appearance, right click on the sun gear and select paste appearance. Or else you can simply select polished steel and drop it on planetary gear and select body. Again do this for planetary gear 2. Drag this and drop on the planetary gear 2 and select body. You can color these gears as well. For that, select edit appearance. Select any color you want and select body. If you have so many components in assembly, then it's better to give color to them for easy understanding. For now, we'll cancel it. Now we'll see how to make motion study animation. Go to the motion study. If you don't have this option here, right click here, select toolbar and select motion manager. Here we don't have motion analysis option. For that, select SOLIDWORKS add-ins, select SOLIDWORKS motion. Now we have motion analysis option here. We can select basic motion as well, but motion analysis is more realistic and very efficient. So select motion analysis. Now select motion study properties. Frames per second, we need 30 frames per second. Click OK. Then select contact. We'll give contact to this all gears. Select this all gears for contact. And click OK. Now drag this key up to 20 seconds. Now we have to give motor. Motor type rotary motor. Component will select sun gear shaft as motor. If you want to change the direction of motor, click on this box of reverse direction. Speed will keep 3 rpm and click OK. Now click on calculate. It will take couple of seconds to calculate. So this is our internal gear, sun gear and planetary gear motion animation. Try to make it. If you have any query, ask in the comment section. Now if you want to save this animation, click on save animation. Select the folder where you want to save. File name, save as type. I always prefer MP4 file type. Aspect ratio 16:9. Frames per second, will select 30 frames per second and select save. Again, system will take couple of seconds to save this animation. If you find this video informative, like this video and subscribe to the channel for upcoming educational videos. So this is our final animation. Try to make it, and if you have any query, ask in the comment section, and thanks for watching this video.